So, just some things I wanted to point out about this topic on hypothesis testing. Now, obviously, when we are looking into the application of all the concepts we've learned already to uh, what we are trying to do in this topic, which is basically about making statistical inferences. Okay, so obviously, a lot of our foundation for this topic comes in what we've learned in the previous couple of topics on normal distribution and also on sampling. I did actually want to make a video on sampling as well, but I don't think it's needed. Please, if you need to, you can pause the video and take a screenshot on how to key in raw data into your GC list using the TI-84. So this is how you calculate some things via the one variable stats app. And this will be useful to you in hypothesis testing if you are given raw data and then you need to key in raw data. Okay, so all this lists just go to on your TI-84, how you get here is you just go to stat here, stats, edit, and then you get here, and then you can key in anything you want. So this screen here, which is this screen here, it's basically like a spreadsheet lah. So you can do one variable stats, two variable stats, and then later on in S6, chapter S6 on regression and correlation, you will learn how to use this one and this one as well, but we're not going to go into those two. So I trust that before you've even gotten to hypothesis testing, you are already familiar with all your key formulae in sampling with regards to what is an unbiased estimator versus an estimate, and also about the central limit theorem and also the meaning of a random sample and unbiased sample and all this. So sampling as a topic, either it will occur together with normal distribution, or more commonly, it will occur with hypothesis testing. And hypothesis testing is what we're going to do today. So if you are not familiar with your concepts in chapter S4 on sampling, please click out of this video now, go back and revise chapter S4 before coming here. Okay, I'm not going to go through sampling because it will just be a lot of me pointing and talking to nothing in particular. So this is what I want to spend precious time going through on a Thursday night. For me, it's a Thursday night right now. Not sure when it is for you watching it, but here we are. Okay, so in this and the previous topic on sampling, you will realize a lot of qualitative answers. Not as much as later in chapter S6 lah. Chapter S6 will really make you question your life because you will be thinking, hey, why on earth am I writing an essay in math? But yeah, you need to know these couple of common qualitative answers. So I think Mr. Philip Ho actually has a set of pretty good summary notes, but I don't dare to show you because I don't want to end up violating copyright laws. So basically, you just need to know what is a random sample and why is a random sample needed. So I trust that we already know the two conditions for a random sample from chapter S4 on hypothesis testing. But chapter S4 on sampling, I'm sorry. But you need to also know why do I need a random sample for hypothesis testing? Because ultimately, right, in front, when I'm calculating my X bar and my S squared, all these are unbiased. You see I've underlined in blue already, unbiased estimator and estimates of the population mean and variance. And a lot of times in hypothesis testing, we are working based on samples because obviously it's impractical to make a hypothesis test by testing the entire population. Isn't it? If you've done science research before, maybe this topic will be a bit more familiar to you because ultimately all the readings that you take during your experiments are just a sample. It's a snapshot of your experimental conditions. And of course, you need to repeat the test over many times. But we do not need to do that in mathematics. We are only given one sample, one trial with which to perform a hypothesis test. So once again, if you have done science research before, these terms, level of significance, p-value, all that will not be that foreign to you. But if you haven't, p-value is basically just the probability of attaining a sample mean x bar such that, and these two values will be unique to the question. So in example 5 of your chapter S5, there is actually an erratum. I don't have the erratum here on this soft copy, but basically, how do I find these two values, A and B here, that are unique to each question context? So when the question asks you, state the meaning of the p-value in this context, you need to state this A and B. So in this topic, there are two normal distributions that you need to use. Please don't confuse them. Please don't confuse when to use them. One is what I call the sample mean distribution, or X bar. You have seen this notation before in the previous topic on sampling, and you will know from the previous topic that x bar follows this particular normal distribution. So this mu or mu naught rather is the hypothesized mean that is given in the question. And then sigma squared over n is the variance, which means that the standard deviation is going to be the root of this thing, standard deviation. So this is the variance, okay? Standard deviation of the x bar distribution is the root of the variance, which is sigma over root n. And this sigma over root n you will see come out a lot in hypothesis testing. Okay, so how do I find this value a and b? Usually, they will only ask you this if it's a one tilt test. Okay, so you will want to look at the level of significance. No, you don't need to consider the level of significance for this, my bad. If it's a one tilt test, they will give you the hypothesized mean mu naught. They will give you the sample mean x bar. So the p-value is the probability of obtaining an x bar, because an x bar is unique to that particular sample one. Or rather, you have samples with the same x bar, samples with the same sample variance. And remember, there is no standard notation for sample variance. You just write those two words, sample variance. Okay, but each sample is unique. So no two samples can have both the same sample mean and the same sample distribution. Okay, so it's the probability of obtaining something in this yellow region or something else in this other yellow region. And how you find this other value if you are given this value is you know that the distance from this value to your hypothesized mean given in the question is going to be equals to the distance between this, which is given in the question, and this, which you need to figure out yourself. So from there, it's more or less just primary school math. And likewise, if the one tilt test is right tilt such that they give you this and this, then you will need to say the other value is going to be this one, where this distance and this distance are the same distance. And therefore, that is how you write it. Okay? Do you need to draw the distribution? For 1 mark, 2 mark qualitative answers, please don't. Especially, I don't think they'll give you that much space even to draw anything that you want to draw. But it will be useful once you are doing hypothesis tests themselves to actually draw the distribution as part of your working. It's not marked, but it will help yourself. Okay, assumptions for hypothesis test, I don't think I need to go through, but I want to emphasize a bit about how do I set up my hypotheses, H0 my null hypothesis, and H1 my alternate hypothesis. So as you know, or rather as you hopefully know after reading the notes, this one is in the case of a two-tailed test. So I know that it differs from or rather I predict, I hypothesize that the true population mean differs somehow from the hypothesized mean. I'm not sure in what direction it differs. So that's why it's a two-tailed test, because there are two directions in which it can differ. On the other hand, for a one-tailed test, I am very clear whether it's right-tailed or left-tailed, it will be given in the question. And can I please emphasize this orange point over here? You need to state by central limit theorem, and every time you use this approximation, you have to write that it's an approximation. Okay, if something is not normally distributed, which it usually isn't, as you will see in a couple examples, you always need to invoke CLT. Okay, and please only invoke CLT if it's sufficiently large. If the question doesn't say those 4 magical words, something is normally distributed, or something follows a normal distribution. Okay, so you either need to have those 3 magical words or 4 magical words in the question. If the question doesn't have those few magical words, you cannot just assume. Okay, if you are required to assume anything, the question will be usually will be very kind to you and signpost by saying something like stating any assumptions that you need. Then of course you will need to assume that it's normally distributed lah. But if n is sufficiently large, if your sample size is sufficiently large such that you can invoke the central limit theorem, CLT, please do invoke it. Okay, but of course don't say your assumption is, oh, I assume that my sample size is sufficiently large. Please if they directly tell you that n is equal to 15 or n equals to 20, you cannot assume something that you know to be factually incorrect. Okay, I think a lot of your tutors will also tell you, Mr. Ho Hussein, who is my tutor, has been saying this like a broken record a lot in class. This topic is the topic that Cambridge examiners report spend the most time about, because people make the same presentation mistakes year in and year out. Okay, so if you need to digest what I've talked about so far, if so far you feel that I've been speaking gibberish and you don't understand anything, please go back to your notes. Please go back to the chapter S4 notes if you have to. I think the sets for hypothesis testing have been pretty. I don't think I'm going to go through my personal notes on this one lah. I'm just going to refer you to this part which is in your notes. Steps in conducting a hypothesis test. I think Mr. Ng Se Tiong went through quite thoroughly in this lecture video. Especially I feel the lecture video, of course, being done by somebody like Mr. Ng, was very well done for this topic. So you can just go back to the lecture videos for the examples, all that. But please, a lot of people forget that you need to state both the I don't know why this says test statistic X. The test statistic should be Z, where Z is going to be your standard normal distribution, 0, 1, and is also equals to that very complicated looking expression. Here. Okay, please note that you have to state or rather define your X bar distribution, your sample mean distribution before you define your test statistic Z. Because this symbol X bar appears in your formula for Z. So if you don't define this X bar, then the reader will not know what the hell you're referring to in this expression. What? Okay, so please go back to this part of your notes. Take your time. I'm going to have a sip of water. Use this few seconds to digest what's on this page. Pause the video if you have to. Okay, are we ready? Fantastic. I'm not going to go through the steps in conducting a hypothesis test because Mr. Ng Se Tiong has gone through very, very well on this and he can explain it a lot better than I can. What I do want to go through, because I feel your HCI lecture notes aren't very good in this aspect, is the reverse questions. So I call these reverse questions in the sense that they give you the conclusion already. So they give you the conclusion of whether you accept or reject the null hypothesis. But remember, in this very complicated looking expression, there are 4 unknowns. 1, 2, 3, 4. So they can ask you to solve for any of these 4 unknowns given the other 3. So for this one, this is the only time you will need to use the Z distribution, the standard normal distribution. So this is the same standard normal distribution that we are familiar with from chapter S3 on normal distribution. Okay, this is just my personal notes. This isn't part of any video I've uploaded anywhere on the channel. If you need to pause and take a screenshot of this or copy this down, how to standardize the normal distribution, please do. Actually, this should have been like that. Yeah, please do take some notes from here. Okay, this is how you standardize the normal distribution, and there are a couple of examples in your notes on how to do it as well. But yeah, please go back to the chapter S3 notes if you're unfamiliar with how to work with the standard normal distribution and how to standardize a normal distribution. But assuming that you have got that sorted out and are familiar with what I'm talking about here, what is going to happen, okay, they are going to give you everything already. So they're going to give you the level of significance, they're going to give you everything else. They just need you to solve for one unknown. It's basically one variable algebra that you learn in set 1, but reframe in a very, very, very complicated and scary way. So what you're going to need to do is you're going to need to use the level of significance to press GC inverse norm function, because after all, inverse norm is when the parameters of the distribution are known, and the area is also known, but I just want to find this value on the axis, this value on the axis, such that it satisfies a given area. Okay, so you're going to have to press your GC inverse norm function. I hope you remember where your inverse norm is. It's just second vast, you go to distribution here, and then normal PDF, normal CDF, etc. Yeah, I don't think I should have gone through this. I just wasted your time, I'm sorry. Yeah, I hope this is still fresh to you. You have been going through that menu all the way from chapter S2 onwards. It's been at the very least 6 to 8 weeks of you navigating to that menu in your TI-84 already. So you should be quite familiar with what I'm talking about. And you need to be aware also that for a two-tailed test, you need to split the level of significance to 2 critical regions. What do I mean? For example, let's say the question say, right? Listen to me for a moment, okay? Let's say the question says, find the values of something, something, something for which you for which you reject the null hypothesis at the 5% level of significance. So let's say, for example, I have 5% level of significance. Okay? So in this case, let's say it's a one tilt test, and I know that it's a left tilt test. So if it's a left tilt test, means that this shaded area, the critical region on the left for which it is rejected, is going to be the area of my level of significance, 0.05. So I will go to my GC, I will key in inverse norm, and just nice, my default already has my standard normal distribution here. Left tail already selected by default, and my area is 0.05. And then I will paste, and inverse norm says that my value is minus 1.644. So I know therefore that this means this Z1 here will be 1.644, and therefore I can write that x bar minus mu naught over sigma over root n is equals to minus 1.644, and then I solve from there is a simple inequality. Okay? And also, you need to know that for a two-tailed test, instead of doing that, I'm going to split it up. So if in this case the question is the same, find the range of values of something in here for which H0 is rejected at the 5% level of significance. But this time it's a two-tailed test. So now it's two-tailed, okay? What I'm going to do is instead of this equals to 0.05, it means that this shaded region plus this shaded region 总共加起来是0.05，所以这个呢会是 0.025. This one is 0.025. So the most quick and painless way to figure out if it's a two-tailed test, just use inverse norm center. So I inverse norm, I switch this to center. Okay, is my area still 0.05, ladies and gentlemen? No, right? Because if this shaded area plus this shaded area is 0.05, area under my normal distribution is what? 1, right? So what's my area from here to here? It's going to be 0.95. My area should be 0.95. So please know what you are pressing inverse norm for. Please know if you should be pressing left center or right tail. And then you will see that now my critical values change entirely if it's a two-tailed test. In general, please be aware that the p-value for a two-tailed test is usually twice that of a one-tailed test. Please be very aware of that. Okay? Copy that down if you have to copy what I just said down. Okay? And then after you form an inequality involving z, depending on whether it's a one-tail or two-tail, of course, the sign of the inequality will change. And then you will solve for the unknown normally using your GC graphing app. Please do not be a clown and go and well, what was I about to say? Oh shit, I'm the clown. Okay. Anyway, please don't be a clown and go and solve your inequalities algebraically like Sec 3 or Sec 4 kid, okay? You have the luxury of a graphing app. Because of these 4 unknowns, right, 3 will be known to you. So just when you key into your graphing app, right, just let the last unknown be x or something. Just press checker x. That's the default unknown. And then after that, you just solve it normally. Graphically. Okay? And then you use your GC, graphing, intersect, etc. to find the unknown quantity. Okay? Now, 2 more things that I would like to point out before I go into the questions, which will be in another video. This video is getting a bit long. 2 more things that I would like to point out before we get into that. The first one is, okay, when you are writing the test statistic Z, always write it in this form. I know it will be tempting for you to suck in the actual values of all of these 4 which are given to you. But that is not mathematically correct. The only mathematically correct way is to write test statistic Z equals to this line. That's all. Do not suck in any values. Please copy what I just said down. Okay? Second thing that I need you to copy is the fact that you write S instead of sigma if you are using an estimate of the population variance. Okay? Because if they do not give you the true population variance or the true population standard deviation, you are going to use S or S squared, which is the unbiased estimates that you have calculated based on the population variance. You are using these estimates, ladies and gentlemen. And so, because we are aware from chapter S4 that the sample variance is always going to be less than the population variance. So therefore, it's not going to be the same thing. You need to write S or S squared in place of sigma or sigma squared when you are writing out this test statistic. Okay? I think in the GST worksheet on sampling and hypothesis testing, Miss Joyce Lee, who created this worksheet, actually summed it up quite nicely here. You need to know how to write it, whether to write sigma or to write S. Okay? And once again, if it use CLT, you need to add one word at the end, approx. Okay? Please be aware of this. Screenshot this if you have to. Can? Okay, so that is it for the concepts in hypothesis testing, just pointing out some things that I feel the lecture video didn't exactly point out in detail. And because this video is very, very long, I have a whopping 5 questions I want to cover. Whether I'll be able to do this in one video, I have no idea. Okay, so somehow, at some point, I will post another hypothesis testing video going through some of these questions. Okay, and until then, hopefully your tutorial S5 will at least have some progress. Okay, because most of these questions are from tutorial S5 except for this one on the left column, which is on the left column because it's from the supplementary exercise. Alright, I hope you found it useful and take care.